In this example, we have two graphs, each with a line, and each line has 3 points. The question is to calculate the slope of the line between the following points on each of the respective lines. Before we can calculate the slope between any of the points on any of the lines, we need to understand what the slope is. The slope is a ratio. It's a fraction. It's a fraction that describes how much vertical change compared to how much horizontal change there is between any 2 points on the line. So some people will write the slope is the vertical change over the horizontal change. As you saw, that took too much space to write that in, and I couldn't actually write all of it out. And so people tend to shorten this. The way they talk about the vertical change is they talk about it as the rise. So the slope is the rise compared to the run. The rise being how much vertical change there is, and the run being how much horizontal change there is. One other thing to bring up is we do have a variable in mathematics that we use to typically represent the slope of a line. The slope is generally represented by the letter m. So we could say that m equals the rise over the run. For the first part of the question, to find the slope of the line between the points a and b, I'll begin by writing that m is equal to a fraction. The fraction will be the ratio rise compared to run. So starting out at point A, I will first figure out that to get over to where the point B lines up horizontally, I would need to move 1, 2, 3, 4 points to the right. And so I'll write that down as a run of 4. Now to get up to where B actually is, I will need to go up 1, 2, 3. So I will have a rise of 3 compared to a run of 4. That gives me a slope of 3/4. It's important to note when you're counting out the slope, if you move to the right, that is a positive run, and if you move up, that is a positive rise. I could have done this differently. I could have started out at this point B and worked my way back to A. Starting out at point B, I would have had to gone to the left 4 points, and because I'm going to the left, I would mark that as a run of -4. I would have then at that point needed to go down 3 units, and so I would have marked that as a rise of -3. So separately, I could have done the same part A and written the slope m equal to a rise of -3 over a run of -4. But what we know from our arithmetic is that a negative divided by a negative still gives us a positive answer. So whether you start at A and work your way to B, or start at B and work your way to A, either way you're going to end up with a slope of 3/4. But it is important to recognize that when dealing with the run, going to the left is negative and going to the right is positive. And when dealing with the rise, moving up is positive and moving down is negative. But if you think about how the axes are oriented, the right side of the x-axis is the positive side and the negative side is the left side. And for the y-axis, the positive part is the up and the negative part is the down. So this orientation lines up very nicely with those. Now we'll move to part C, that we want to find the slope of the line between the points A and C. So we will again begin stating m is equal to a fraction, and starting out at point A, I will then need to move to the right 1, 2, 3, 4, 5, 6, 7, 8 points, giving me a run of 8. And the rise will be a positive 1, 2, 3, 4, 5, 6. So between A and C, I see the slope is 6/8. But again, treating this as a fraction because every ratio is a fraction, 6/8 reduces down again to 3/4. What makes a line is that it has a fixed slope, so that no matter which 2 points you pick on this line, the slope will always work out to be the same. So no matter which 2 points I pick off of this line, whether it's any of the 3 that we've got here or any other point that this line goes through, it will always have a slope of 3/4. Now moving to part B of this, and on the other graph, we need to find the slope of the line between the points D and F. So I'll begin by stating m is equal to a fraction. From point D, I see that I would need to move to the right 6 units to line up with F. So that would give me a run of 6, which becomes the denominator. To get from the height of D to the height of F, I will now need to drop down 4 units, which gives me a rise of -4. And -4 divided by 6 is -2/3. In part D, we now want to find the slope of the line between F and E. I'll begin at F, and I will work my way back to line up with E. So my slope, m, is equal to, I can see I have a run of -3, so that's my denominator. And then to get to the height of e, I have a rise of 2. So my slope becomes 2 over negative 3. If we divide that out, a positive divided by a negative is a negative 2/3. So again, what we found is no matter which 2 points I picked on this particular line, we came up with the same slope, negative 2/3. It never matters if you move from D to F or F to D. The direction you go will always be compensated by the signs on the rise and the run. The other important thing to point out right now is that in the first graph, which had the points A, B, and C, we ended up with a positive slope. Whereas in the second graph with D, E, and F, we had a negative slope. Earlier we've talked about the fact that the slope will capture two concepts, whether you're walking uphill or downhill, and secondly, how steep is the line that you're walking on. A positive slope will always be an uphill line. As you move left to right, you're always going up. It's an increasing line. A line with a negative slope will always be a downhill line. It'll always be a decreasing line. So when you're given a graph of an increasing or decreasing line, without doing any calculation, you should immediately know whether that slope will be positive or negative. The other component is how steep it is, has to do with the value of the slope. So the positive or negative captures whether you're increasing or decreasing, whether you're going uphill or downhill. How steep the line is will be determined by the value of the slope. The bigger the value of the slope, the steeper the line. While it's hard to see in these two examples, a slope of 3/4 is greater than a slope of 2/3, and so the line with a slope of 3/4 is going to be a steeper line than the slope of 2/3. The steepness will become more obvious the more examples that we continue to work on.